Hello everyone, welcome to Tech with Machines. We are going to have a 150-day challenge. The challenge is all about solving different kinds of data structure and algorithm problems, understanding the patterns, and also able to crack your coding interviews. The list is going to be quite exhaustive and it is going to be most commonly asked interview questions. Don't worry if you are a beginner or if you struggle with the data structure and algorithm problem. I also struggle with data structure and algorithm problem, but together we will achieve this. So let's solve one problem every day. Before we dig deeper into the first problem of our first day, please remember to give a thumbs up and subscribe to my channel. So our first problem is called TwoSum. TwoSum. What does this mean? It means that we are given an array of n elements and a target number where we have to find any two elements which can lead up to that target. It will be something like this as an example. Let's say A is an array and we have four elements inside A, which are 3, 1, 5 and 6. And we are supposed to find any two elements which can lead to a target of, which we are naming here T, of 9. So if you can see here, 3 and 6 are leading to the sum of 9. Let me try to use a different color to highlight this. I will rub this and we will use, let me draw it again. So we have 3, 1, 5 and 6 in our array, and as an answer, as I said, we are saying that 3 and 6 can lead to a sum of 9. Right? Those are the two elements which can lead to a sum of 9. There is a possibility that we are given altogether a different array which doesn't lead to that sum, which doesn't have any elements which can lead to that sum. So as an example, we have an array of 3 elements, 3, 1, 8, and the target which we have been given is of 2. So as you can see, we don't have any two elements in this array which can sum up to 2. There is also a possibility that we are given, let me try to add to this itself. So let's say we are given here 2 and 2, and the target is actually not 2, and the target will change to 4. So as you can see here, there are two pairs basically which can lead to a sum of 4. One is 3, then there is 1, then the other pair is 2 and 2. So 3 and 1 can lead up to 4 and 2 and 2 can be 4. So we have two pairs and we are supposed to return any pair if they exist. So this is all about the problem statement. Now, as you know that generally a data source or a data structure problem is solved using a brute force approach. We will not spend time in coding a brute force approach. If you want, please let me know in comments. We'll go through the brute force approach as well. But to save time, as it's a 150-day challenge, we will directly go to the optimized approach. As it's an array problem, generally you can remember that arrays, if it is an array problem and you are supposed to sum, maybe you can think about using a space of some kind of a space to solve that problem. So in this, we will try to use a hash set or a dictionary to hash map or a dictionary to solve this problem, right? So let's come to the array where we have actually the sum. So 3, 1, 5 and 6 and the target is 9. Though we're not going to solve the brute force approach, but we'll still go through it. Let's say if you had to do it without an optimized solution, what will be your basic approach? Your basic approach will be that you will iterate. You will have actually 2 loops, because you will have to iterate through each element and then compare it with every other element to see that whether those 2 elements can add up to 9. So we'll start with 3 and then add 1 to it, which will say it's 4, so it's not the sum. Then 3 and 5, it's not the sum. Then 3 and 6, it's a sum. So that leads up to the target of 9. So 3 and 6 are the values which are supposed to be returned. In this case, we're not supposed to return the numbers. Instead, we are supposed to return the positions of those numbers. So in this case, we will be basically returning, so this is 0 index, this is 1, this is 2, and this is 3. So basically the output of this particular, let's say it's O, will be an array of 2 index positions, which will be 0 and 3. So if there is no 2 elements which are leading to a target of 9, we will return an empty array. Now with brute force approach, the time we are taking to solve this, that means our time complexity is basically big O of n square. Why? Because we are iterating through every element in a nested loop. So we are basically doing iteration, nested iteration. So that leads up to a time complexity of order of n square. Also, we are not using any extra space, so the space complexity is basically constant in this brute force approach, so it will be order of 1. Now, how can we optimize this particular problem? Generally, order of n square can be optimized to linear time, so we can solve it in order of n. We can try to solve it in order of n, and as I told you, as a common pattern, if you are trying to solve an array problem, maybe you can think about using a space, which would mean that your time complexity will become linear, but along with it you will also end up using some space. So your space complexity is also going to become order of n. And how? Let's see it in a minute. Finally, let's solve this problem using our optimized approach, which means using an extra space, which will lead up to the space complexity of order of n. As we are going to code the solution in Python, I will mostly refer to the data structures used in Python. So we are going to use dictionary here. In case you are using Java, then it will be hashmap. You can code this particular problem in any language you prefer. Mostly the logic is going to be pretty much same. So let's call our dictionary and initialize our dictionary initially as empty dictionary. It doesn't have anything. And we are going to iterate through each element and find the difference first, and if that difference exists in the array, then we have found the pair. What does that actually mean? It actually means, if you remember in your academics, you might have figured out if x plus y is equal to z and you are given x and z, then you can find y. So in this case, our x is number 3, our y is not known, and our z is number 9. So if I have to find y, my y is going to be 9 minus 3, which will lead to number 6. Let me correct this. So this is going to be 9 minus 3, which is going to be 6. So which means for 9 to be computed from 3, I need 6 as well. So 3 and 6 both has to exist in my dictionary. In this case, 3 is already there in the array, and if the dictionary has the 6, which means 3 and 6 both exist in the array, and these are my elements which are leading to 9. So let's try to do this with our dictionary. So as our first element will be 3, so with 3, our difference will be 9 minus 3, which will be 6. But 6, because the dictionary is empty, so 6 doesn't exist in the dictionary, we will put the number 3 in the dictionary with its index position, which is 0. So this is our first entry in our dictionary. Now we'll go to the next index position, which is 1, and at that we have a number called 1. We'll find the difference again with the 9, and 9 minus 1 is going to be 8. Again, 8 doesn't exist in the dictionary, so we will put 1 with its position, which is 1. Now the next element is 5. We are again going to find the difference, which will be 9 minus 5, which will be equal to 4. Now 4 doesn't exist in the dictionary, so we are going to write 5 in our dictionary, and we are going to save its position as well, which is 2. Now at the index position 3, we have 6, which means our fourth element is 6, and we do 9 minus 6 and we get 3. And if we check in the dictionary, yes, it does exist, which means the 6 which is at index position 3 and the 3 which is at index position 0 is our output. So we get the index position from the dictionary and the current index position, which will lead to the output of 0 and 3. So as you can see here, by using a dictionary and finding a difference against the target sum, we were able to find a pair. And as we iterated through every element, and we ended up saving almost every element in the dictionary, the space complexity of this problem and the time complexity of this problem is ending up linear. So now let's try to code it in Python. As we are done with the dry run, now let's try to solve the problem. If you remember our equation x plus y equal to z, which means we were finding y variable by doing z minus x. And also we managed a dictionary called nums. So we are going to do that first. So we are going to create a dictionary called nums, and initially it's going to be an empty dictionary. Now, fun fact about dictionary in Python. Dictionary is generally a key value pair, and it is unordered and mutable in Python. The keys are generally expected to be immutable because they are supposed to be unique, and the values can be any object. There is another method called default dictionary, which you can use to provide default value to all the elements in the dictionary. So that is all about dictionary. Now we are going to also have a result array. Again, array is mutable in Python, and to add element in an array we do append, and to add element to a dictionary we actually use the scare subscript and provide the key, and against that key we give the value. We will just see it about in a minute when we will iterate over the array. Now here, as you can see in the find pair, there are two inputs given, a as an array and target, which is 9. Now first what we will do is we have to iterate over the array starting from the index position 0. Now if we need an index position 0, generally in Python you can do for I in range and then provide the length of the array, which will be basically the last index position, or you are actually trying to tell that give me an iterable from 0 till the length of the array, which in this case is 4, so you will get 0 till 3, and the last index is always exclusive, so it is going to iterate only till 0, 1, 2 and 3. But to get an index and the value directly, we can just use enumerate. Enumerate just gives a counter against each element in an iterable. So instead of doing this, we can say give me I and give me the value, let's call it x, in the iterable a, so that I can use them directly. Now in this case we know that we are going to return the result, so let's return it. In case there is nothing, it will return an empty array, right? So now in the iteration, as we know, that the first thing which we'll do is find the difference, find the y. So which will be the target minus the current element. So our target minus x is going to be the difference. Now we want to know if this particular difference exists in the dictionary. So we can do that with the in operator in Python. So we'll say if diff exists in the nums, then we will just return so we can say result dot append, or simply just say return and give the index position of diff which is there in the dictionary, as well as the I which is the current index position. Why I am taking the index position first from the dictionary? Because that has already been added, which means that's the initial index, or that's an early index. So in terms of giving the result, I can give result in any order, but in terms of giving the result in an increasing order of the positions, I am first fetching it from the dictionary. So if it is not there in the dictionary, then we are just going to add that key to the dictionary. So in this case, to nums, as I told you earlier that you can use a subscript, so you are using subscript here, and your key will be nothing but the number itself, which is x, and against that you will add its index position, which will be I. So with this, we are able to find the actual pair which will result into this particular target. So let's run it. So we are going to run it here in the console. So I will do Python and the file name, which is TwoSum.py, and as you can see, I got the index position 0 and the index position 3 as an output. Now if there was something which was not leading to the target, then I'm expecting it to give me an empty array. So let's give it and run it, and it leads up to the target array of empty. So this is how we solved our first problem. And if you have stuck to the end of the video, I'm proud of you. You have solved your first problem, and the difficulty level of this problem is quite easy, if you can see. And if you will practice it again and again, you will remember. Just time your coding solution so that you know that how quickly you are able to solve it when you practice it multiple times. I hope you liked the video, and if you did, please remember to give a thumbs up, like, and do subscribe.